Testing isn't just a box to check at the end. It pays off throughout development. Unit tests are required by norms and standards, but system-level tests give us more extensive feedback on whether the full system behaves as intended. Early system-level testing helps us catch issues when fixes are still quick and inexpensive, rather than later when they get costly. By testing only on the final hardware, we will never be able to verify every single detail of the medical device, as we will never be able to run every line of code and trigger every possible interaction between the individual components. It is easy to imagine that. For example, we cannot verify that all components react to a faulty or missing communication partner as intended, since we would need to break each component during the test scenario. And although it is fun to intentionally break stuff at times, it is not very sensible. It is better to choose a testing strategy that allows us to verify the behavior on system level before the device is fully ready. This is what we call environment simulation. With this approach, we keep only the system under test as a real device and simulate its environment. In this approach, we benefit from all those advantages that simulations bring. For example, due to replicating various components within a virtual environment, we do not need physical devices for those components. This way, we can save hardware costs. This is especially relevant when the individual components are developed at different sites or during supply bottlenecks. By instrumenting the interfaces of the component, we can test it on system level in a virtual environment. This approach is called software-in-the-loop testing. This way, signals can be exchanged via virtual networks. This approach is not limited to virtual networks though, and transmission of data can be realized for all kinds of interfaces. Usually, the first step in this testing approach is to test only the application layer. In this case, data is exchanged directly rather than via a transport protocol. In a simplified image, we see the boundaries for hardware and software-in-the-loop testing. With hardware-in-the-loop or HIL testing, we verify the behavior of the full device, while software-in-the-loop or SIL testing allows us to test the core software. With virtual networks, we gain the possibility to include the transport protocol layer in our tests. Now you might be wondering, why would I want to double all test cases to be able to run them for SIL and for HIL? The great thing is that we do not need to do that. Because we are testing the same requirements in SIL and HIL, the test cases do not differ. Only the interfaces change. And within a good simulation and test tool, both paths are supported and you only need to care about the application layer itself. And you can decide whether you want to do SIL or HIL testing on the fly. You might be wondering now, is it worth to invest so much time in the beginning of the project for creating digital twins, prototypes, virtual environments, and adding a new testing phase with software in the loop? Yes, it definitely is. All the time you are spending, and let me tell you, it is much simpler than you might think, will be gained by a multiple in the final stages of the development, especially during the integration phase.